Okay, so they give you an equation, and they say find 3 solutions for the equations, and here's your equation they gave you, and then they want you to graph it. They pick their own points. They pick -1, 1, and 3. So if x is -1, you would say 2 times -1 is -2, minus 3 gives you -5. Here's their x, here's their y, so they made an ordered pair, an x and a y. If x is 1, 2 times 1 is 2, minus 3 is -1. So they made an x and a y. If they change x to 3, 2 times 3 is 6. 6 minus 3 is 3, so they made an x and a y. Let's say x is 2. 2 times 2, you put 2 where x goes, is 4. Minus 3 is 1. So you would have 2 as your x, 1 as your y. Does that make sense? How they got their ordered pairs? So they just wrote their ordered pairs right here underneath. So then we graph it. So you have 2 different ways you can graph it. You can graph it by the ordered pairs, or you can graph it by the equation. So the first thing I'm going to do is graph it by the equation. Let's see if it's the same line they got. Here is always their starting point. This is how much you start with. And this is always your slope. Slope is rise over run. They give me a rise. What's my run? Over 1. So let's see. I should start at -3. -1, -2, -3. And your slope is up 2 over 1. 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 Is it the same line they got? Yep. Let's look about ordered pairs. This is always your x. This is always your y. So you're always going to go over, then up and down. Right? X goes over, y goes up and down, right? So they go over to -1, down to 5. They put a dot there. Then they said over 1, down -1. Over to 1, down to -1. Over 3, up to 3. So did it work either way, putting the dots or using the equation? You can do it either way, right? So there's a few questions that your assignment's going to ask you. They're going to say, well, if this is your equation, you have y equals 2x minus 3. Your 2 is your slope. Your -3 is your starting point. What's going to happen to the equation if your slope stays the same, your starting point goes to 5? Where would I start now? 5. So 1, 2, 3, 4, 5. And your slope is the same, so up 2 over 1, up 2 over 1. So up 2 over 1, up 2 over 1. What I also do is down 2, backwards 1. So down 2, backwards 1, down 2, backwards 1, down 2, backwards 1, down 2, backwards 1. What happened? Well, if I could draw a straight line. What happened? Parallel lines. But they want you to say, well, where's the second line, your new line, compared to your first one? It started at where? 5, and your first one started at 3. So your new line is higher on the graph, right? Because 5 is bigger than -3. Is that pretty easy? Your new line started higher. What if you kept your starting point the same, but your slope was different? Let's say your slope is 4x. You would still start at where? -3. But your slope is now up 4 over 1. Up 4 over 1, right? So you're going to go up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. This line, what do you notice about this black line compared to the original red line? Yeah, they cross because they start at the same spot. But is it steeper or less steep? Steeper. If you're trying to climb up that red line, it would be hard. If you tried to climb up that black line, it would be even harder, right? So you need to write down, the higher the slope, the steeper the line. The higher the slope, the steeper the line. Okay, so for the next one, they give you the equation y equals 2x plus 1. They plugged in x each time, and they got a y, right? They got an x and a y, an x and a y, an x and a y. So, what's your starting point? 1. And your slope is up to over. So does it work every time? Down to over 1. That works every time. What's going to happen if you keep your slope the same, but you make your starting point -4? Where's the new line going to start, Madison? At -4. So what is it going to be compared to the red line? It's going to start where on the graph? Well, is -4 higher or lower than 1? -4 is less than 1, right? So it's going to start lower on the graph. And when I graph it, it's going to give me a parallel line, right? These lines parallel? Yes? So if it says, well, what happens if your starting point's at -4? You would say, well, you would start lower on the graph, right? What about if the starting point stayed the same, but your slope went to a -3x? What do we say about slope? The higher the slope, the steeper the line. Okay, so let's look. I start at 1, but now I have down 3 over 1, down 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3 over 1. Can I also go 1, 2, 3 over 1? Right? So if I connect these dots, give me a pretty big one. That's a thick line. So what happened? Is it going the right direction? Oh, why is it flipped directions? Because it's a negative. So this was a positive slope, right? And this is a negative slope. So it flipped directions, right? And the absolute value of 3 is higher than the absolute value of 2, so your line is steeper, right? So now it's negative and steeper. So Jackson has 2 hoodies. His mom buys him 4 or more hoodies every month. So it had to say the same thing, hoodies and hoodies, right? Or if it was dollars, it would be dollars and dollars, or cats and cats, or whatever. It has to be the same thing. So let's say this is 0, 1, 2, 3. Let's plug them in. 4 times 0 is 0. Plus 2 is 2. 4 times 1 is 4. Plus 2 is 6. 4 times 2 is 8. Plus 2 is 10. 4 times 3 is 12. Plus 2 is 14. Okay, so I can either graph it by doing my x, y points, or I can graph it by doing my line. We're going to actually do it both ways. Okay, over 0 up 2, over 0 up 2, over 1 up 6, over 1 up 1, 2, 3, 4, 5, 6, over 2 up 10, over 2 up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are all the points I can put on this graph, right? Now let's graph it using our line. Where's our starting point? 2. He starts with 2 what? Hoodies. And he goes up how many hoodies? 4. 4. And so I have my rise. My run is going to be 1. So up 4. 1, 2, 3, 4 over. 1, 2, 3, 4 over. Ooh, something's off there. Let's see. And that last point was over 2 at 14. Oh, I just went up over 1, 2. I accidentally went over 3. Okay, here we go. If I start at 2, can I also go down 4, backwards 1? I go down 4, backwards 1. Down 1, 2, 3, 4, backwards 1. 1, 2, 3, 4, backwards 1. Right? So Here's my line. It looks like that. Is it a positive or negative line? Positive, because it's going uphill. Right? So now I need to know what my independent variable and my dependent variable are. My dependent is always my total, right? So the dependent is going to be the total number of what? And my independent is whatever x represents. What does x represent? X represents, Jackson has 2 hoodies. His mom buys him 4 more hoodies every month. So X represents your months. What would happen if Jackson started out with 10 hoodies? Your line would start where? Higher, right? What if Jackson's mom only bought him 1 hoodie every month? The line would be steeper or less steep? Less steep. So if this number is bigger, the line starts higher. If it's lower than this number, it starts lower, right? If your slope, if it gets bigger, your line is more steep. If your slope gets smaller, your line is less steep. Yes? Okay. Says Ashley wants to save money for the purchase of a new tablet. The equation is T equals 7W plus 15. So your total equals 7W plus 15. It represents the total amount of money in dollars Ashley can save after W weeks. So we know W represents what?
Weeks.
Weeks. So let's put 0, 1, 2, 3, 4 in. We're going to say 7 times 0 is 0, plus 15 is 7 times 1 is 7, plus 15 is 7 times 2 is 14, plus 15 is 29, right? 7 times 3 is 21, plus 15 is 7 times 4 is 28, plus 15 is 43. Okay, let's graph it. I can go over 0. This is always my over. This is always my up, right? Over 0, up 15. Over 1, up 22. Over 2, up 29. Over 3, up 36. Over 4, up 43. There's my line. If I could draw a straight line. Okay, I could have also said, well, we start at 15. I go up 7 over 1. 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 I could have done it that way, right? What's my dependent variable? Dependent's always my total. Dependent's always y. Yep, this is my dependent variable. It's always y. It's the total saved. My independent variable is number of weeks. It's always my x. What does 15 represent in this problem? What does 15 represent? I know it's the starting point, but what is the starting point of what? Since Ashley wants to save money for the purchase of a new tablet, the equation T equals 7W plus 15 represents, yeah, that's her starting. So she started with how much money? Started with 15 and she saved how much? $7 a week. So what if they change the equation to y equals 10W plus 15? It would be what? It would be more steep because she's saving more money a week, right? What if they kept it at $7, but she started with $25? Then your graph would have started where? Your graph would have started higher at 25. And the relationship between x and y is every week she saves more. Every week she saves more money because it went up. What kind of relationship is that? Positive, negative, or no slope? It's a positive relationship because they're both going up.